Today we're going to be looking at the line of best fit. We're going to look at scatter plots that show a correlation between a set of two variables, and we're going to be finding the line of best fit. The line of best fit can also be called a regression line. Is it obvious from the name what a line of best fit is going to be? Let's look at this last graph over here first. When I have data and it's all spread out and it doesn't make a line, it doesn't make a curve, it's just random, that's called no correlation. Back over here to this first graph. Do you see that it kind of makes a straight line? And it's going up. Since it sort of looks like a line, that's called a correlation. Since the data is going up, that's called a positive correlation. And we're going to learn how to find the line that's going to best fit that data. Do you see that this data kind of makes a line that's going down? That's called a negative correlation. Okay, next. Here we have a table with some data. Does it look like it has some correlation? Does it look like positive correlation, negative correlation, or no correlation? See, it kind of makes a line and it's going down. By the way, what is this table showing us? It's showing us CD sales starting in the year 1999 and giving us the amount of sales per year. First of all, do you even know what a CD is? Do we? A CD was a little round disc that we bought, and it had music on it. And so why would the sales have started going down? Don't we still listen to music? Do you listen to music on a CD? No. We started having digital downloads, and so CDs were not sold as much anymore. And what we need to do is take the data points and make them into a table. We're going to use Desmos to find the line that best fits this data. Now, most of the time when we have years, we don't put them in like this because we're lazy and we don't want to type all those big numbers. And so when we have years, we usually change the first year to a 0 year, and 1, 2, 3, 4, 5, and the year 6 would be representing the year 2005 on our chart here. Now, if we're going to find a line, what do we need to know? We need to know the slope, and we need to know the y-intercept, and I need to explain to you what this R is representing. So we're going to open Desmos. Desmos Texas version. You have it open? And we are going to click on this plus sign and then a table. And we're going to enter our data. The first data point was 0, 930. And then 1 goes with 940. 2 goes with 880. 3, 810. 4, 740. 5, 770. 6, 705. Now, before I go forward, I'm double checking my data Because if I type in the wrong numbers, am I going to get the right answer? Now, those are data points, but I can't see my data points over there on the graph. If you want to see the data points on your graph, you have to change the scale of the graph. And so I'm going to click over here on this one that looks like a wrench. And my X values, I don't like minor grid lines, so I usually take that off. My X values go from 0 to 6. I usually go a little bit more so I can see that last point on my graph. My Y values go from, the lowest one is 705, so I might want to go to 700, and the top one goes to 900 and something, so I might want to go to 999. And now can I see my data points? You don't have to, but if you wanted to see your data points, that's what you would have to do. You would have to change the scale. Now I'm going to have Desmos figure out the line for me. I'm going to type in y equals mx plus b, but I have to type it in a certain way so that Desmos will figure out the line for me. Do you see up here on your chart, it doesn't just say x and y? What does it say? X1 and Y1. So I am going to type Y1. I just typed Y1 and Desmos automatically made it into what's called a subscript. It automatically did that little lower one. Now I need not an equal sign, but approximate sign. There's at least two ways to get that. I can go down here to this keyboard, ABC, and this little curvy line right here. And then I want to click this off so that it's not in my way. So the way I got that, keyboard, ABC, this one right here. Or I actually prefer to use my keyboard. Do you see this little symbol up on the top left-hand part of your keyboard to the left of the number 1? You can do Shift and hit that corner point, and you can also get that. So whichever way. And then I do y equals mx1 plus b. Do you see that Desmos gave me a line, and that is the line of best fit? This number right here is my slope. Do you see my slope is negative? Why is my slope negative? The line is going down. And this is my y-intercept, and this number right here is the R number, the correlation number. Do you see that correlation is a negative number? Because the line is going down. The closer this is to 1, the closer my points are to making a perfect line. Do my data points make a perfect line? No, but pretty close. And so that's why that is a 0.9 or a 0.95. And the farther that's away from 1, the farther my data points are away from the line of best fit. If I had a correlation of maybe 0.5 or 0.4, that would be almost no correlation at all. That would mean the points are really spread out all over the place. So the closer that R number is to 1, the closer it is to the points making a perfect line. So then I would go back to my paper. Lost my mouse. There he is. I would go back to my paper and I would write down that slope and that y-intercept in an equation. Take that slope and that y-intercept we got off Desmos and make it into an equation. Now, we did this as kind of problems previously. Do you remember doing this a couple of weeks ago? We're going to add one more step to it. Now we're going to predict what happens if the trend continues. If the trend continues, how many CDs would be sold in 2006? 2006 is my target year. Where did I get this number? Way back over here when I first had this, what is my first data point? That's my first data point, and so that's where I got the 999, and, oops, I'm on the next problem. So, my first data point, my prediction, and that would be 7 years. In place of the X, I plug in the 7, put this in your calculator, Desmos, and that gives me the number 660. In the year 2006, if the trend continued, 660 million CDs would be sold. Million, because that's what the original table was written. So what we're going to be doing today is extending the line and predicting what could happen next. Here's another set of data. This is the population of Arizona in millions on July 1st. Most of the time when we have dates, instead of typing in all of 2001, we just change that to a 1. That is simply to make typing easier. So, I would take that data and type it into Desmos. The first year was 5.3. The second year was 5.44, 5.58. Fourth year, fifth year, sixth year, delete, delete. Double check and make sure you have typed in your data correctly, because if you don't have correct data, you can't have a correct line. Now we need to make our line of best fit. Y1. Shift approximate. MX1 plus B. When it did that, if you want to look at the data points, we would have to change this again. Let's see, our data points this time, 1 through 10, that would be okay, but this is going to have to be, maybe something like 4 to 7. I always want to go a little bit smaller than my lowest point and a little bit more than my highest point. So if you want to see the data points, you have to change your scale. You don't have to see the data points. But I did want to point out, do you see that these points are much, much closer to the line than our previous example? And then this R number is 0.99 this time. It's closer to 1 than on my previous example because my data points are closer to making a perfect line. R is a positive number because I have a positive slope here. And so we would write down our slope and our y-intercept and use those to make an equation. The equation would be 0.6 1717x plus 5.094. I got those two numbers out of Desmos and wrote it down in an equation. So if this started and 1 represents year 2001 and 2 represents 2002, then if I want to find the population in 2020, that would be 20 years later. So I would substitute in the 20, not the whole 2020, because when I put it in the computer, I took off the first 20 and just used the last number. Put that in the calculator or Desmos, and you get 4.528 million people. Now, just want to point out that when we put this on the graph, it pretty much made a straight line. Many times, population, though, is not linear, it's exponential, and we'll be looking at that tomorrow. Well, how many data points do I need in order to use this line of best fit in Desmos? All I need is 2 points. So I looked up yesterday, the population of Pasadena in 2010 was this number. And the population in 2020 is this number. These are actual data points for Pasadena, Texas. If the data is linear, what would the expected population in 2030 be? Now, again, just to make it easier to type in the computer, instead of typing in 2010, I'm just going to use 10 and 20, and then I'll use 30 to answer that last question. So, in Desmos, I am going to add a table. And my table is just going to have 2 data points, 043, 151, 891. If I'm going to look at my data points, I am going to have to change my table and the Y is what's got to change. It's got to be 100,000 to 200,000. I'll let the computer set that. So do you see the data points? In order to see the data points, you have to change your scale. I went from 0 to 30 in the X direction and 100,000 to 200,000 in the Y direction. To see the line, I have to type in Y1, shift, squiggle, MX1 plus B. Do you see the R value on this one? What's the R value on this one? 1. Because when you have 2 points, 2 points can be connected with a perfect line. Anytime you have just 2 points, the R value will be 1. So, I take the slope number down here and the y-intercept number down here, and I write the equation for the data. There's the slope, there's the y-intercept. 30 years later, I put in the number 30. This is the population that would be expected in the year 2030 if the data is linear. As I mentioned, the data may not be linear. It might be exponential, and then we'll have a different equation. Please copy this definition down into your notes.